Today's lecture is a continuation of chapter 5, problematic soil. As you remember that in problematic soil we said that there are many types of problematic soil that are found in Egypt: collapsible soil, swelling soil, and soft clay. And we said that there may be another type that we are going to add at the end of the lecture. So we are speaking about 4 types of soil. In the previous lecture we reached till soft clay soil, which is the 3rd type of problematic soil that is found a lot in Egypt. And we took few pages or few slides from this lecture. We're going just to remember them very quickly to start from where we ended last time. We said that for soft clay, we gave the locations. They are all near the shore. Alexandria, Kafr al-Sheikh, Damietta, Manzala, Port Said, always near the shore. And we said that why does this type damage the structure? And we said that it is because of the highly compressible characteristics of this soil that ends up with having very high deformations in our structure. We said that the problem of this soil that it is very, very soft to the extent that I cannot carry it from the soil to the lab. So having a sample to be tested in lab, the probability of having a sample is 0% or 1%, something like this. So usually if I get a geotechnical report with all the data based on the lab, then I expect they have ignored the soft soil because they did not get samples. So to judge a geotechnical report in a place where I expect to have very soft soil, I should check the presence of field tests. In case I do not find any field tests, then I will say stop, this report is inadequate because they did not perform on-site testing. So what type of on-site testing? We said that we have something this called shear vein or vein shear tests. This test, it's a vein, or as I said, it's a double blades that are perpendicular to each other, and it is immersed inside the soil. And I try to apply a torque to revolve or to rotate this double blade, this one, inside the soil. The more stronger, the stronger the soil, the harder it will be for me to revolve this. Imagine that this is immersed in very good sand, you cannot move it. But if it is in clay, but it is good clay, you will have some difficulty. But if it is in soft clay, you will find that it is like putting a spoon inside a soup. It's nothing. It is going very easily. So this is what we do. We just rotate it 90 degrees, 360 degrees, and once we rotate it, we calculate the torque that we needed to for this action. We said that in the Egyptian code they have given us values from here. We can get the value of the resistance of the soil. Based on the value of this resistance, or from another test which is, you remember the SPT test? We said that the SPT test is a test where we put a tube in the soil and we just hammer on top of it for a fixed distance and so on. In case of very soft, this amount, this number of blows, as you can see here, it is from 0 to 2. If you remember that in each part of the test, the number of tests was usually, say, 10, 15, 20, and the total would be in the something like 30, 40, something like this, very big values. But here I'm speaking from 0 to 2. 0 to 2 to move the sampler 30 centimeters. It's nothing. It means that the soil is very, very weak. So in case I get a number of blows from 0 to 2, it is very soft. From 2 to 4, it is soft. From 4 to 10, it is medium. Usually in soil, if I get a number of blows of 10, I reject it. It is very small. So imagine we are speaking about numbers that are less than 10. So anyway, we have now n values. It can be also used to decide if this soil is very weak or not. Based on this, I can use tables given in the code to decide that it is very soft clay or soft clay based on the shearing resistance or based on the number of blows that I have counted. Also, there is another CC, compression index. It's another test that is done in the lab. But remember that when I have a sample at the lab, it means that I could get a sample. So I doubt that I can get these values from the samples that I will get. I will always get soft clay, but very soft clay, it is very difficult for very soft clay to reach the lab. Therefore, it is better to have the test conducted on site, as we said. Now we reach this we can say that this is the start of our lecture today from page 47. How can we deal? Now we managed, we said that what is the type of the soft clay, how can we classify it, and how can we test it. Now, how can we treat it? I know it is soft clay, so our very soft clay. What should I do? For soft clay, we have a special operation that can be done, which is preloading. Preloading means that I will go to the site, put loads on the soil, so that these loads affect the soil in its current condition. Due to this load, we said that it is clay. It is full of water. Permeability is very low. So if I leave the load for a long time, what will happen? Water will start to leave the soil, and the soil will be better. So once I remove the load and put my building, in this case, the soil has already settled. So that's why we call it pre-loading or pre-compaction. I try to compact the soil using loading. But of course, as I just said, it is what is the problem of this is that it needs a very long time. I can use this if I have a site, and I know that next year I will be working in this site, and I know that this site has a problem. So I just go very quickly, early, maybe construct an embankment on top of the soil. So this embankment will induce stresses on the soil, and I leave it for months or maybe a year, and then I come again, remove this embankment, put my building. In this case, I managed to preload the soil before going there. There is another thing. Sometimes we can do something to make our preloading or the compaction of this soil quicker. Instead of having to leave this load for 1 year, maybe I can leave it for 3 months and it would work. How? Many ways, but to think of it, if I have water passing through soil with very low permeability, if this water has to move 2 meters, it will take a certain time. But if I wanted to move 4 meters, it will take double this amount, 6 meters, triple, and so on. So if I manage to collect the water from inside the site and not to wait for the water to leave the site, then I will make this operation faster. Because when you put a load on top of this is your soil, this is your site, and I put a load on top of it. In this case, I will wait for the water that is below to leave the site and to go to neighboring sites. It will take a long time. But if I manage to put some tubes all over the site, and these tubes can suck the water, in this case, this will be quicker than what I expect. So there is methods. I'm not going to go through it because this can be discussed in a lecture called soil improvement. But we just know the name or know the criteria. The criteria is that I put tubes or whatever drains I can put so that it helps in collecting the water from the soil rather than waiting for the water to leave the site. So when I collect it, I make the operation faster. So preloading is very good for clay. The disadvantage of it is that it takes very long time. If I manage to shorten this time, then in this case it will be very effective because maybe 2 or 3 months everything would be finished. The procedure of shortening the time is diversity. There is a lot of procedures, a lot of methods. It needs discussion, but all you need to know is the criteria of it is that we do this to shorten the duration. Vertical drains. Vertical drains is just what I was saying now. Vertical drains, these are the tubes that I insert in the soil to help me to collect the water. It is like a drain, but it is vertical in the soil. Instead of water having to leave the site, maybe moving 100 meters to leave the site, no, I do a drain every 5 meters. So water will just have to move 2.5 meters in each direction to reach this drain, go vertically up, and then I collect it and take it away from the site. So instead of water moving 100 meters, it is just moving 2.5 meters. So the difference is big. So this is vertical drain. Another type is called stone columns. Stone columns is a type of vertical drains, but instead of using, of course, these vertical drains are like tubes to collect the water. I use a double function. I use a tube to collect the water, and I fill this tube with stones. So I'm doing 2 functions. I'm collecting the water, and I'm reinforcing the soil. Instead of having clay all over, no, I am having clay and columns of stones. It is like piles, but from natural material, putting just stones. So stone columns and vertical drains have the same operation, but stone columns reinforces the soil because the material used in this type of vertical drain, it's a vertical drain, but it is full of stones. These stones give more reinforcement to the soil, and the soil can carry more load. So this is another good type of material. By the way, this type is supposed to be very cheap, and we use it here in Egypt in many cases. But unfortunately, due to some construction procedures, and there isn't enough equipment to conduct these stone columns, the price of stone columns was elevated. It raised a lot, and it became very expensive, to the extent that in some projects we prefer to use piles rather than to use stone columns, because they were supposed to be less expensive, but actually it became the same. But this is a special condition here in Egypt in a special time. Maybe in future we have adequate machines, and we don't have a lot of projects needing these machines, so we can use these stone columns effectively. There is a type called electrical method. Electrical method, you know what is osmosis? Osmosis is, I put something with high osmotic pressure, so this high osmotic pressure sucks water it is what happens with the roots of the plants, how the roots of the plants get water from the soil, because it is the osmotic pressure inside the plant is in the root is high, so it attracts water inside. We do the same. We do high osmotic pressures in some location, so it attracts the water and take it away. It is not found a lot in Egypt, but know the criteria so that if in case you face it. Soil stabilization by adding various materials such as lime, cement, and fly ash. These are additives that are added to the soil to improve the quality of the soil. Of course, the main problem will be, how can I'm adding it to soil that is already existing? I'm not transferring soil from one place to the other and adding something to it. No, soil is in place, and I want to introduce some material to come to this soil. How come? It will be very difficult, because at least I will need some kind of pipe to inject this material into the soil. And how can I ensure that this material is going to reach all parts of this soil? It is a little bit difficult. So number A is the best economic solution. Number E is the least economic solution and the least feasible solution. So, and in between, all of them are okay, but it depends which is possible at your project. There is another, the last type, which is type F, dynamic compaction. Dynamic compaction is a method that I can compact the soil in place using deep compaction. I can introduce compactors to go to deep locations and deep depths and compress the soil. It's a way, but of course it is less feasible than all of these before, because it is very expensive and it needs very special precautions. Here, the choice of which method to improve the properties of the soil depends on the characteristics of the clay, the depth of the layer, and the area of the project, the type of structure. Each project you study, and maybe I tell you that number F is the least important, but maybe in your project it is the only feasible way, because maybe you have the equipment from a previous work nearby, and you have the experience because you have already done this, and you have a very good contractor, and you have all the material that is needed. So number F may be the best for your project. So, but when I put this characterization which is better, it is a general case for all projects, but your project may be different from them. Types of foundation. I prefer really this. I prefer to deal, it's either I replace the soil, for me this is very good, or I change the type of foundation. Maybe I go to a better type of foundation that is not affected by the clay. I have, say, 4 meters of soft clay, 10 meters of soft clay, the big amount. I cannot remove 10 meters, so why not put piles to reach the good soil below? I don't have to think of was my improvement adequate or not. I leave the soil, I leave the problems of the soil, and I concentrate on the foundation. This is a very good approach because I know that I have already finished everything. I don't expect that in future soil will cause any problem for me. But here, if I do not conduct the operation very accurate, it may affect my structure in the future. So you are the one who is going to judge which is better for your project. For your project, which type of foundation you are going to use. Always our first choice is, as we just said before, shallow foundations is my first choice. In any project, I should think of shallow foundations. Why? Because shallow foundation is the cheapest type of foundations. Why it is the cheapest type? Because, of course, it is small, and I do not put only steel reinforcement at the bottom. I don't have upper steel, so the amount of steel in the foundation is very low compared to other types. So shallow foundation is the best type. But is it good for soft clay? No, it's not good for soft clay. I should not go to it unless I am forced to do it. Here, shallow foundations are rarely used in case of soft clay. Rarely. But if I have to use them, then I will have to take additional precautions. Similar to what? Use tie beams, ground beams, but use them very big, very stiff, so that in case I have some differential settlement between footings, then these ground beams would help in acting, the whole of my foundation would act like a grid. It's one grid connected with perpendicular beams in all directions. So in general, shallow foundations is not the best type for this type of soil, but if I use it, then I have to take into the consideration that is given in the Egyptian code for using this type. And I said the best thing is the ground beams to have very stiff and rigid ground beams that would help the foundation type to survive. The next one, deep foundations. Deep foundations. Why didn't I say raft? I just skipped raft. I started with shallow foundations, and then I went to deep foundation. Because actually shallow foundations include raft, because shallow, it means isolated, combined strip and raft. But raft, I'm not gaining any benefit, because raft is good in case I have soil that may differ from one location to the other, so the raft would bridge on any abnormalities. But in case of soft soil is usually a big layer all over the soil. So what will happen? Instead of sinking down with your small foundation, you're going to sink with the big foundation. It's the same. You're just adding more to your losses. So it is already included here, but we did not mention it because we are not gaining any benefit out of it. The other is deep foundation. Deep foundations is the best type, of course. For deep foundations, we have two types of elements that would help me in carrying the load. What are these? The friction along the pile. If you have a pile in the ground, then this pile is surrounded with soil all around. So this pile will be carried by the soil around it. And in the same time, the end of the pile will rest on the soil. So the end bearing of the pile is another portion of the load that is carried. If you want to carry your bag, you can carry it by two ways. Either you do like this, you just surround your bag with your hands, it will not fall because I have friction between my hands and the bag. If I open my hands, the bag will fall. So it is the friction that is carrying the bag. Or I can carry it like this from the bottom. This is end bearing. This is end bearing. This is friction. So these are the two ways for carrying piles inside the soil. In soft soil, I'm pushing my piles inside the soft soil to reach the good soil. What about the friction with this soft soil? Can I depend on it? No. So in this case, frictional forces are minimum because it will be the frictional forces in the portion of the good soil. But in the portion of the soft soil, it is zero. I don't consider it. To the contrary, it's a problem. Why? Because soft soil is neighboring to the pile. And it is touching the pile. But soft soil, with time, it will settle because of consolidation. So in this case, instead of carrying the pile, it will be carried by the pile. Because the soil wants to settle, and the pile is standing. And they are close to each other. So usually soft soil is considered as what we call negative friction. It is a load on the pile, not carrying the pile. So this is what we have to discuss. Frictional resistance of the soft clay with the pile is not reliable, but rather it is considered a negative friction that increases the value of the load on the pile. So take care in case of using deep foundations that the portion of the pile that is penetrating this soft soil is adding to your problems, not solving your problems. He is not carrying your pile, but to the contrary, with time it will consolidate and it will induce additional loads on your pile. So you have to take it into consideration. My load will depend on the end bearing of the pile, as we said, the other type, which is the end bearing of the pile. This will help me in carrying the load. To drive a pile group for a structure in a limited area, it is preferable to drive the piles sequentially. Yes, this is something related to pushing the water. When you push your pile inside the soil, it pushes water. So imagine that you started by doing piles all around your site. So actually انت حزمت الموقع. You make a fence around your site. Water will not be free to leave. And then when you try to put your piles inside, you will face a problem. Water cannot move. But it is better that you start from one direction, put your piles. Every time you push your pile, it pushes the water in one direction, and so on, continue in the same direction. So finally you put all of your piles and you end up having water outside. sometimes pushing one pile may rebound another pile, because water is pushing and it may push the pile up. Anyway, this is something related to construction, just for info. The last type of problematic soil, we said that we have three main types of problematic soil. These are the collapsible, expansive, and soft clay, and these are the major things. But there is another type, and it is found not in soil, it's found in rock, and it is a very big problem. In Egypt it is not found a lot, but it is found, so we have to know it in case we may face it. You look at this photo, you see here, this is called a sinkhole. Sinkhole means that we have a cavity inside the rock, and the top of this cavity or cave collapsed inside. So what happened? When it collapsed inside, everything on top of the soil will fall. Here you have a cavity that is very, very below here, very deep below here, and this surface was not strong enough. So what happened is that all of this area collapsed inside. There was a building on top of this area, and it took it inside. So it is problem. Maybe I may show you later a photo for some of these sinkholes in Egypt, but they are limited. They are not this catastrophic. They are limited, but they will cause problems. Of course, even if it is a limited problem and you have one of your footings on top of it, it's a problem, because if you have a settlement of 5 centimeters, it's a problem. So imagine that you have a settlement of 50 centimeters, not this amount, but 50 centimeters is a lot. It will cause failure to your building. So this is what we call sinkholes. How are these sinkholes? How does they happen? How they are formed? There are many approaches for them to be formed. One of this, we call it solution cavities. There is some type of rock that when water comes, it dissolves the rock. This is very important for you to understand. And it's found in Egypt. الحجر الفرعوني, which is called limestone. This limestone, if you subject it to water, but not for 1 year or 2 years, for a long time, maybe millions of years, you will find that it will start having fissures, cracks, and these cracks will extend to the extent it may be like caves inside this material. So water coming on top, dissolving some of the rock, and the water going in these caves or fissures, so this end up with something like this. This is called a sinkhole. Or you have a cave that was going at the below here, because of also the solution cavities, and then the top of the cave became loose. So what happened? They fall down. This is another type. You have 2 layers, a layer of stone and of rock, and a layer of cohesive soil or even cohesionless soil, but cohesive to be very fine particles. So what happened? The fine particles with the water will go inside these fissures, and it will cause a collapse on top. Here similar, but this is just a minor effect, because what you will see is just a depression in the topsoil, not a big sinkhole. Here also 2 types of rock. One that can include caves, and the top cannot include caves, but because of the caves that is in the below one, the top rock collapsed. Here, similar to the one on the top, but this is cohesionless soil and this was cohesive soil, just different shape. Why are we given these different shapes? Because you will be asked to go to a site and to check this site. So what you have to think of, what is the shape of the, if you go to a site and you are on top here, or on top here, or here, or there, or here, how can you expect that this will include sand dunes? This one especially, seeing minor depressions in the soil means that, especially when these depressions are rounded, it means that there is a big possibility that below you have sinkholes. So these are just given for you so that you can judge the top formation, the surface formation, of course, to know how sinkholes are formed, also to help you when you go to a site that you may discover this phenomena before doing any site investigation, to expect that you may have sinkhole at this location. This ends up our lecture for the problematic soils. We said that we have 3 types plus 1, which is the sinkholes. We discussed everything related to it. I think it may help you in some of your projects, and it will help you in the future if, in case you meet something related to problematic soil. Thank you, and see you next lecture.